In this video, we will review what it takes to prove triangles congruent. Perhaps you remember that there are 5 ways that you can prove triangles congruent. Side, 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 angle, side, angle, side, angle, 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 side, or hypotenuse leg. Notice that things that are not on this list are side, side, angle, or angle, angle, angle. These combinations of information will not allow you to prove that triangles are congruent, in which case we will circle we can't prove triangles are congruent. So let's see. For part A, we have angle, side, angle. Okay, so angle, side, angle. Part B, this is what side, angle, side looks like. 2 sides and the angle between them. So that is side, angle, side. Now part C is clearly side, side, side. Alright, we got all sides. Now part D, this would be side, side, angle if there was such a thing, because this is 2 sides and the angle that's not between them. But side, side, angle is one of the things that does not prove triangles are congruent. So we're not even going to write that down because it doesn't exist. Instead, we will put that we can't prove the triangles are congruent. Okay, for part E, now this would be side, side, angle if this was just a regular angle. But because this is a 90-degree angle, that means we're looking at right triangles. So perhaps hypotenuse leg. So notice that the hypotenuse is marked congruent and one of the legs is marked congruent. So hypotenuse leg will prove these triangles are congruent. Now here we have 2 angles and a side. Now we've already used angle, side, angle. So why isn't this angle, side, angle? Well, I have 2 angles, but the side is not between the 2 angles. So that's when we use angle, angle, side. Alright? So when the side is between the angles, we put the S between the A's. When the side is not between the angles, we do not put the S between the A's. Mark each diagram with anything we know with certainty, then give a reason we could use to prove the triangles are congruent. Well, in addition to what's already marked, we know that side BA is congruent to side BA by the reflexive property. So that means that triangle ABC, okay, is congruent to triangle ABD by, this would be angle, angle, side, because I have 2 angles and the side is not between them. Now, what's not marked yet on this picture is vertical angles, which are always equal. So now I see that these 2 triangles will be congruent by angle, side, angle. I have 2 angles and a side between them. So the congruent statement is triangle ABC is congruent to triangle DBE. Alright, it's important that you match up the corresponding angles. It should be in the same order. Let's see, got to scroll down a little bit. So we are given that angle B and D are right angles. So I can go ahead and mark those. Alright, that means that they are congruent as well. C is the midpoint of BD. So here's BD. So if C is the midpoint, that means that BC is congruent to CD. And in addition to that, we know that these vertical angles are going to be congruent. That gives us angle, side, angle. Alright, so triangle ABC will be congruent to triangle EDC. BC bisects angle DCA. Please notice angle DCA is up here. And if BC bisects that, alright, that means that this is the bisector. Which means that this green angle is being divided equally. So these two smaller angles are congruent. So we can mark that. We're also told that BC is perpendicular to AD. Perpendicular means that it's forming 90-degree angles. So we've got that. Now, because of the reflexive property, the shared side, CB, is congruent to CB. So we can mark that. That gives us angle, side, angle. Two angles and the side in between. So triangle ABC is going to be congruent to triangle DBC. Okay, now we're going to write a couple of proofs. So let's see, we're given that angle B and angle D are right angles. Alright, so angle B and angle D are right angles, given. Well, that means that angle B is congruent to angle D because right angles are congruent. Now, we're also given that C is the midpoint of AE. Alright, fine. But that means, so here's AE, so that means that AC is going to be congruent to CE. Alright, so segment AC is going to be congruent to segment CE. And of course, that's the definition of midpoint. Alright, they just said C is the midpoint, so these are congruent by definition of midpoint. Now, in addition to that, well, that's the end of the given. So what else you got? Angle ACB, okay, ACB is right here. What's that going to be congruent to? Well, we are talking vertical angles, so that will be congruent to angle ECD. Because vertical angles are congruent. Okay, that's enough information for us to say that triangle ABC is congruent to triangle EDC by angle, angle, side. Alright, we have two angles and a side that's not between them, so that's angle, angle, side. But we want to prove an additional statement, an additional piece of corresponding parts. So angle A would be congruent to angle E because those are corresponding parts. And we know that corresponding parts of congruent triangles are congruent. Alright, which we will abbreviate CPCTC. But corresponding parts of congruent triangles are congruent. Let's do one more proof. BC bisects DCA. So we talked about this a minute ago. But look, here's DCA, and along comes BC, being a bisector and whatnot. Always got to be a bisector about it. But being a bisector means you're cutting something in half. In this case, we're cutting this angle in half. So we're given that BC bisects angle DCA. but that means that angle ACB is going to be congruent to angle DCB by the definition of angle bisector. Okay, and then we are further given that BC is perpendicular to AD. Alright, so here's AD. So if it's perpendicular, by definition that means that CBA and CBD are right angles. That's just the definition of perpendicular working for you. Now, if these two angles are right angles, that means these two angles are congruent. That's always going to be the very next thing you write. So that we will write that angle CBA is congruent to angle CBD. Okay, because right angles are congruent. Okay, so far all I have is angle, angle. Is there anything else I can mark? Sure. I know that the shared side CB is going to be congruent to itself. So I can say that segment CB is congruent to segment CB. And that is the reflexive property. Reflexive property. Okay, now that gives me enough information to say that triangle ABC is congruent to triangle DBC. Because of angle, side, angle. Let's spend a moment talking about parallelograms, and specifically we'll deal with a rectangle here. With parallelograms, the opposite sides are parallel. Keep that in mind. But the opposite angles are always going to be congruent. So if this angle is 70, then this angle will also be 70. Now, these angles are consecutive interior angles. So these are always going to be supplementary. So if this is 70, this other angle has to be 110, because they have to add up to 180. For the same reason, this will be 110 as well. Alright, these consecutive angles of a parallelogram always have to be supplementary. Notice that it works if I had circled them the other way too. Right? So what if I circle these? These are also consecutive, and they are also supplementary, aren't they? Okay, now my picture looks way too messy. So, OCD. Now, what about this? So, parallelogram still. Please remember that if I take a parallelogram, so the opposite sides are parallel. If I throw a transversal in there, alright, which is the diagonal, notice how it forms a Z. And the top and bottom of the Z are parallel, which means that these alternate interior angles are congruent. So that tells me that this angle right here is going to be 60. Okay? Similarly, I can make a different Z. Because these sides are also parallel. Alright, I guess this Z is going to look a little bit more like an N. Alright, that tells me that these angles are going to be congruent. Okay, so what about it? Well, these angles are opposite angles. So if this is 70, then this is going to be 70 as well. You know, I guess I don't really need the whole z thing, but all I really need to do is subtract from 180. So I guess I don't need the z. Alright, because I have 2 out of 3 angles. So if I do 180 minus 60 minus 70, that's 50. So that tells me that I'm going to have 50 here, and it's the same math over here. So that'll be 50. Okay, now a rectangle is a parallelogram. So everything I've been saying applies to a rectangle as well. But in addition, because it's a rectangle, we know that these corners are all 90 degrees. Alright, which means that the angles that are right next to each other are complementary. They have to add up to 90. So if this is 50, then this must be 40. Alright, so that allows me to jump all around this picture. Yeah, baby. Remember the z business I was talking about before? I feel like I can throw in some n's and z's real quick. So, for example, look at this n. Bam. 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 Alright? 50 is in the corner of the n. So that's going to be congruent to this 50 down here. And if this is 50, then this is 40, because they have to add up to 90 degrees. Okay? Now, here's something a little bit new. Because this is a rectangle, that means that the diagonals are congruent and they bisect each other. So what the bottom line of that is, all 4 of these segments are going to be congruent in a rectangle. Alright? All 4 pieces are equal. That means I've got isosceles triangles all over the place. Now, what's special about an isosceles triangle, right? If I have an isosceles triangle, and so that means like these sides are the same, the base angles are congruent. So like if this was 35, then this would also be 35. So that's going to happen here in this isosceles triangle. If this is 40, then this will be 40. If this is 40, then this will be 40. Alright, all of these triangles are isosceles, so these are all base angles. If this is 50, then this will be 50. If this is 50, then this will be 50. Alright, now that allows me to find the angles in the middle by subtracting from 180. So for example, these 2 angles together make 80. So that means this angle up here must be 100, because that's the only way it's going to make 180. Alright, these are vertical angles, so that's also going to be 100. Now, I could either jump over here and say like these two 50s make 100, so that means this has to be 80. Or I could have used the fact that this was a linear pair, and I could have said, well, if this is 100, then this is 80. Alright, so many ways to think about it. These are vertical angles, so these are 80. So many ways to think about it. Either way, we found all the missing angles. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.